Okay, good day again. So this is the last lesson on your chapter 4, which is your hypothesis testing. So for the last lesson, we have the topic hypothesis testing and population proportion, which is represented by your P. So at the end of the lesson, we have formulate the appropriate null and alternative hypothesis on the population proportion. Second, we need to compute the test statistic value. Third, draw the conclusion about the population proportion based on the test statistic value and the rejection region. And lastly, solve problems involving hypothesis testing and population proportion. Okay, so again, we have usually we are using this in your qualitative research involve hypothesis testing. So, involving proportion and percentages. So, you want to test the null hypothesis that an unknown population proportion is equal to some hypothesized value, which is represented by your P sub O. And that is, this time, as you can see, we're not using population mean. Instead, we are using null hypothesis is population proportion is equal to hypothesized population proportion. Okay, so we have only three steps here. Okay, three possible alternative hypothesis. So same, we have the not equal to for the non-directional or two-tailed test. We have the greater than, which is your population proportion is greater than to your hypothesized population proportion that is determined by your quantifier or your symbol greater than, and that is known as the right or upper tailed test. And lastly, we have alternative hypothesis, which is your population proportion is less than your hypothesized population proportion. So again, we could use z-test for one population proportion. Suppose that a sufficient large sample size n is randomly drawn from a population. For a randomly drawn sample to be sufficiently large, the rule of thumb is NP is greater than 5. So we will going to multiply your sample size times your population proportion. It should be greater than 5. And n times 1 minus p should be greater than 5 also. Okay, now, so for a large sample case, the central limit theorem justifies the use of the approximate z-test with the z-test statistics. Okay, so that is given by the formula for population proportion. We have z is equal to p hat minus p sub o. P hat is your sample population proportion over standard deviation of p hat. Okay, so the standard deviation of p hat is given by the square root of p of your p population proportion, p sub o and q sub o, k over n. So where p hat is equal to x over n, and x represents the number of successes in the sample size n. Successes meaning those are already surveyed and have answered the survey. So the table below summarize the critical region. Okay, so same rules, only the representation is applied, is the different one from the previous lesson. Okay, so still we have decision rule, reject if your z is less than negative z over c sub alpha over 2, or z is greater than z sub alpha over 2. So for two-tailed, we have here for two-tailed, that is not equal to. that is not equal to, for the not equal to, or both have this what we call, see this word with or. Okay, and for the left-tailed, we have the less than. Okay, now, so example, a certain shipping company conducted a survey on the passenger satisfaction with their service. The survey show that 182 of 250 are satisfied, okay, with their service. Is there sufficient evidence that the population proportion of passenger that is satisfied with the company's service is significantly lower than 65%? So use 1% level of significance. Okay, so solution we have, so using the critical region approach, facilitate the null and alternative hypothesis. So we have here null, the proportion of passenger is satisfied with the company's service is 65%. For the alternative, the proportion of passenger that is satisfied with the company is significantly lower than 65. Okay, so now, so if we were going to use that in symbol, null hypothesis, which is population proportion is equal to 0.65, and your alternative is population proportion is less than 0.65. Okay, so take note, we have here the word significantly lower. Okay, the question is there sufficient evidence that the population the proportion of passenger that is satisfied with the company's service is significantly lower than 65%? Okay, so we have now the steps. Of course, we will still follow the steps. Okay, so we are done with step 1. Step 2, specify the level of significance, which is 0.01. Take note that we are using lower tail test or left tail test. That only means that your level significance will not be divided to 2. Okay, so we are using the directional test, which is your left tail test or lower tail test. For step 3, of course, we will going to compute. Okay, so take note, we have your p hat is given by your x over n, and that is 182, which those who agree, over 250, which is your sample size. So we have 0.73 for the p hat, and of course we have for the q hat, we have 1 minus p, or the initial value of those who agree, and we need to know who disagree. So that's 1 minus 0.65 is equal to 0.35. Take note, 0.65 is already given. That is given by your 65%. Okay, now, so for your next step, we have establish the or compute the statistics. The test statistics. Okay, so let's continue. We have z is equal to p hat minus p initial p or initial population proportion. So over initial population proportion times q sub 0, okay, over n, that is 0.73, which is your p hat, minus 0.65 over 0.65 times 0.35 over 250. Okay, so z is equal to 2.67. So take note, our critical values are so we have 0. Based on our level of significance is 0.01, that is negative 2.33. So take note, 2.67 is above negative 2.33. Okay, so since statistical test is lower tail test, z is equals to 2.67. So the critical region is given by z is less than negative z sub alpha. So again, this is a left-tailed test or lower-tailed test. Okay, so since the computed test statistics do not fall on the critical region because 2.67 is not less than negative 2.33. So z should be less than negative 2.33 for it to belong to the rejection region. So that only means that we will going to accept the null hypothesis since 2.67 is greater than negative 2.33. So we could conclude that there is no enough evidence at 1% level of significance that the proportion of passenger that is satisfied with the company's service is significantly lower than 65%. Okay, so that is how you're going to test your hypothesis. Okay, so using your p-value, of course, same process. Step 1 for step 2. Okay, so we have 0.01. Same step 2. For step 3, this is where it differs. Okay, so we have, of course, we need to compute still the z value. Okay, that's 2.67. And then, since z, which is equal to 2.67, is the area of critical region, and in the z table, we have that at 0.9962. And one-tailed test is used. The area is multiplied by 1. Okay, why 1? Because again, it is one-tailed test. If it is two-tailed, then we will going to multiply that to 2. Okay, hence p value is equal to 1 times 0.0110, which is 0.9962. Okay, decision rule for that is that we reject if p value is less than or equal to alpha. Otherwise, we accept it is more than. So p value is 0.9962, which is should be less than 0.01. But remember that 0.9962 is greater than 0.01. Thus, we will going to accept the null hypothesis since it does not agree that p value is less than a. So in order for our value to be in the rejected region, it should be less than 0.01, and 0.9962 is not less than 0.01. So therefore, we will going to accept the null hypothesis, which indicates, we have that earlier, that there is not enough evidence at 1% level of significance that the proportion of passenger that is satisfied the company's service is significantly lower than 65. Okay, so that's it for your lesson 5. Okay, we have already your lesson 3, lesson 4, and lesson 5 for your chapter 4, which is hypothesis testing or testing your hypothesis. So I hope you learned something, and this will be your last lesson for this quarter. Okay, thank you and have a great day ahead.